So to kick things off, I guess there's a little legal matter that I have to put up here. Although this product is very close to being released, it's still a preview, and we're going to actually talk about the roadmap and where this is going in terms of how AppDynamics is integrating with the mainframe by leveraging some technology that IBM has built. And so we're gonna, and that was kind of the AppDynamics legal disclaimer, and this is the IBM legal disclaimer that we're gonna be talking about future direction and future path for mainframe visibility in IBM. And so the basic goal here, and regardless of what you've listened to today, both in the keynote and ongoing, is really understanding that customer experience and the customer journey. You heard about business outcomes and obviously the movement of the Business IQ platform towards that. But when you kind of break it down, the goal is that we're trying to really touch our consumers and our end users and evoke some kind of emotion. But the other thing is that users want convenience. They want to be able to access their data and their accounts at any time and any place. So it's really about the convenience and feeling attached to your brand, attached to your business. And obviously you want certain outcomes to happen, whether your users are internal or external. You want certain things to occur in terms of what you want the application to do. And in order to do this, they interact with applications. So your users using applications. And this customer experience obviously culminates on having the right type of experience from a performance perspective as well. And so this end-to-end path and end-to-end journey is critical when trying to understand customer experience, improve customer experience. And so it's really not just about the technology. And as a software vendor, you know, we could tell you the technology is going to solve everything, but it's really about the process and the people behind that, and culminating that is the technology around people and process to make it efficient and leverage that to improve your customer experience and understand customer journeys. And so digital disruption, which we haven't actually talked a lot about at this conference, but is a common topic, is really understanding how businesses have changed and how things evolve quickly. So when you look at the way that IDC looks at the market, you essentially have three main platform disruptions, and you can see underneath that the turnover in the Fortune S&P 500 index. So the 500 biggest companies in the world and how this has changed over time. Now the first platform is really the invention of computing. So this is your typical mainframe architecture. We started making business processes efficient with computing. Now the second platform is when we move more towards client server. So we started creating the ability to compute in smaller form factors, interact with servers and clients and going back and forth. And the third platform is really about cloud and IoT. So leveraging the cloud, we can create new types of businesses, new efficiencies. And that's really what this third platform is. And IDC kind of predicts these in 18-year chunks as we kind of transition between them. And I'll go as far to say that beyond the third platform is potentially how things move towards edge computing, and we really start to see hybrid environments become the reality and the norm. So that's kind of where IDC thinks things are going, but as a result of this, disruption and business change is real. And so they predict in the next 10 years that 75% of the S&P 500 will be replaced. And so your goal is to be in the 25% that are not replaced. And that means that you have to innovate on top of a lot of existing, let's say, technical debt and existing systems that, that underpin your business and your business processes. And so the other interesting thing is that there are certain transformative technologies and kind of technical leaders that do certain things that result in these greater efficiencies and better business outcomes. And so some statistics around that are really additional revenue growth for companies that are able to capture these digital moments and have these digital experiences. And of course, greater profit margins, because computing is more efficient than throwing people at the problem, so to speak. The other piece is using new types of analytics and machine learning to better predict and understand patterns and behaviors, not just for your customers, but actually all the data that your enterprise collects. And of course, reducing operating costs is another key area. But as you reduce operating costs and you create new ability to innovate, leveraging things like cloud computing, there's still a lot of traditional infrastructure underneath these new platforms. So we still have to balance that, the innovation with what our business runs on today, on investments that we've made in the past. And so it's really critical to understand how things evolve and change and how we can adapt what we built before to the things that we're building now. Over to Nathan Bryce, who is actually the leading product manager from the IBM side on the work that we're doing together to provide visibility into the mainframe.
Hey, that's great. Thank you very much, Jonah.
Thank you.
So we've heard from Jonah about these 3 waves of technology and how clients that have managed to embrace that disruption and use it to drive change are reaping significant business rewards, right? They're still here. But one of the things that's in common with those enterprises that have lasted through this period, they've got very deep technology stacks, right? So as Jonah mentioned, you're building on one layer of technology onto another. And for many of these customers that are still around today, at the absolute center of that technology stack is an IBM mainframe. So whether you look at the insurance industry, banking, retailing, airline, all of these industries, many of the largest enterprises out there are running on an IBM Z platform. And the reason for that is pretty clear. So the picture here is of the latest Z14 mainframe that was announced earlier this year. And this machine's capable of running 12 billion encrypted transactions per day, right? And if you're a worldwide retailer or a large credit card provider, right, this is the sort of scalability and volume that you need to meet the challenges in today's world. And the stat at the bottom here is really interesting as well, and I think this is one of the key reasons why we're still seeing a lot of workload running on the platform itself. So more than 2/3 of the production workload still today in 2017 is being run off the mainframe, but that's only at the cost of 6% of the total IT spend. So it's an incredibly cost-effective platform to run your core systems of record today. So there may be some of you in the audience here who are perhaps not as familiar with the mainframe as myself or some of the guys that are working with it all the time, right? So there's a lot of acronyms on the mainframe and interesting phrases, so what I wanted to do was just give you a very quick high-level view of these different, what we call subsystems that run on the mainframe, what they are, what they do, so the later charts here actually make sense for you. So to begin with, looking at Kix Transaction Server, IMS Transaction Manager, these are transaction managers, right? So you can think about these as being mixed language application servers. Traditionally, this sort of workload was written in languages like COBOL or even assembler. Today, you're more likely to see something like Java running on the mainframe. But essentially what these subsystems do for you is the ability to run transactional workloads. So if you imagine you're booking a holiday, right? You want to be able to book a flight, you want to be able to book a hotel room, but you don't want to be in a situation where you press buy on a website and you suddenly find that you've managed to book the hotel room, but some problem with the flight and that was cancelled, so you've suddenly got a hotel, but you can't get there with the flight. So this is the essence of transactionality. And this is what these systems are set up to do. So enable you to sync at a certain point in the application, make sure everything runs successfully, and if there are any problems, roll everything back, right, before you commit those changes. So as well as the transaction managers, you obviously see databases running in the back end. So DB2 is probably familiar to a lot of people, but also more mainframe specific things like IMSDB. And then typically there's a layer of messaging middleware to enable you to interact with these applications, and an MQ is probably the common one that we see on Z today. So I'm the product manager for our mainframe monitoring products, right? So my day job is looking after the folks that are living and breathing the mainframe. They're part of that siloed mainframe team. And I don't know how many people have seen 3070 screen here in the audience, right? Very, very different look and feel to the AppDynamics screens that you'll see up everywhere else today. But believe me, if you're a ZSME or a systems programmer, right, you can navigate through this type of interface using keyboard shortcuts at the speed of light. If I tried to take this UI away from some of our, from our power users, I'd have a very, very, very unhappy customer. Now, obviously we have more modern looking, GUI, mouse-driven UIs into the product, but I kind of wanted to show you this to let you know that this is still being used today, and it's being used very, very productively as well. So the Omegamon family itself is really there to give you a full stack capability of managing and monitoring your mainframe today. So across all of the key subsystems that I mentioned in the previous chart, it enables you to see your entire mainframe estate in one screen and understand what's going on and go quickly do that deep dive analysis and root cause problem identification. And just to kind of put the portfolio in context here, there's a wide range of different Omegamons. You can purchase them individually, so if you wanted a monitor to look after the z/OS operating system, you can buy that standalone. But increasingly our clients are buying these things in suite packages. So the base package here kind of contains everything you need to do basic platform monitoring, then you add in the performance management suite to bring in the kicks and the IMS and the messaging, and then also the service management suite brings in our automation tooling. We also have links out into the other IBM Z portfolio, so out into our DevOps offerings so that you can get integration between your monitoring and your DevOps tools, out to our analytics tools, and then what we're going to talk about today, which is the linkage out into what we call hybrid service management and the Z APM Connect offering. So when I'm talking to clients today, this is a picture that we hear a lot, right? Teams are siloed, and this is because teams have been built up, over a period of time. Different teams use different tooling. They don't get full visibility of the entire application. They're looking in at their own particular silos, and they've got their own views, and no one can see the full picture there, right? So the problem with that, of course, is that applications span end to end here. So as we're looking at these large enterprises that have got these large technology stacks that are being built and developed and added to over many years, this is getting increasingly complicated, which is why there's a real need for tools like AppDynamics to see right across that estate. So what I want to do now is just give you a little bit of a view of the personas involved here and what might happen when you see a problem in a shop today that has AppDynamics installed, but it has a mainframe as well. So I'd like to introduce you to Chuck here, who is the IT ops practitioner. He's using AppDynamics to see the application, and he's really worried about the SLAs of that application, making sure everything is running well. And if anything goes wrong, he wants to be able to go find out which component is causing the trouble and hand over to the person that's going to do the deep dive analysis and root cause determination. And on the right-hand side of the screen here, you've got Jim. So Jim's what we call an SME on the mainframe, a subject matter expert, and he's using Omegamon here to do his deep dive problem analysis. He's in there, lightning flying from his fingers as he's navigating through the 3070 screen, but he doesn't see the big picture of the whole application here. So Chuck is looking at a view like this today, right? So if you're using AppDynamics today and you've got a mainframe, this is what you're going to see. That single icon up at the top there that is called kicks, that's a mainframe as you would see it today. So you can see the time that the transaction goes into the mainframe, you can see the time that the transaction comes out, so you can tell if something starts to go wrong that it's a mainframe issue. What you can't do is tell which of the components or the subsystems within the mainframe is actually causing you the trouble. So you end up having this sort of conversation. So Chuck is using AppDynamics to monitor his application. AppDynamics is generating an alert. He can see that there's this performance deviation. He can see that things are starting to slow down. And he can see that it's in the mainframe. So what does he do? Well, he knows it's using MQ to contact the mainframe, and that's the kind of the first point of entry in there. So he phones up the MQ SME. He takes a look at the message queues. There's nothing really going on there. No queue depths are too high. All kind of looks fine. So she knows that the problem, or rather that the transaction will next flow into Kix. So she phones up the Kix SME, who's taking a look at the different Kix regions, looking at the health of those regions, the CPU overhead. And again, it's kind of like, well, everything kind of looks good to me. But he knows there's a back-end database call that's being made. So he's wondering maybe it's a problem there. So he phones up Jim. Jim is finally able to understand what the root cause problem is here. So in this particular case, it's a transaction that's waiting on a lock that's causing this slowdown. So now you've got to the root cause, so you can start to do your problem determination and fix this application issue. So this is exactly the problem that we are looking to fix with IBM Z APM Connect. It's really to address that problem, reduce the amount of hops you would take, and enable you to get straight to where the problem actually is. So Z APM Connect really came about because in the mainframe side of things, we realized that there was a gap in the market in monitoring mainframe data in APM software. So, like I said, my team specializes in mainframe monitoring. We've got the expertise there. We understand the platform. We understand the characteristics of what you need to have agents running on the mainframe. And so what we started doing was to work with the IBM offering. We introduced an offering last year. But the feedback that we got from clients is the quote that you can see up here on the right. So many of our clients have already made a choice to go with AppDynamics. It was the feedback we were getting loud and clear, and they were really interested in the capability, but they needed to see that in AppDynamics. So about this time last year, we started partnering. I met with Jonah in San Francisco. We looked at the code and the technologies, and we thought we had an opportunity here to partner between us, right? So I'm interested in making sure that the mainframe is a first-class citizen in the whole APM world, right? So not seen as a problem child that's off in the corner and somehow different to all the other platforms, but able to be seen as anything else. And for AppDynamics, many of the largest enterprise customers in the world have got some really core system of record style applications running on a mainframe. And that was a gap in their capability today. So there was a perfect opportunity to partner. We announced the partnership back in March at the IBM Interconnect conference. We've been working together. We've had a number of beta releases. And then 2 weeks ago, we've actually announced the new offering, IBM Z APM Connect. And it will be generally available a little bit later this year on December the 8th. So this is what you see with Z APM Connect installed. So the AppDynamics components here that you can see within the dotted circle, this previously would have been that single icon on the flow map. Now, you can actually see that you've got, in this case, an HTTP transaction flowing into Kix. That's going from one Kix region to another Kix region. It's making a backend DB2 database call. So suddenly you've got insight into all of those different subsystems that are running on Z. You know which of all those different teams, where that problem's happening, and you can go directly to that person in order to get that fixed. So let's have a look at how this experience should be with Z APM Connect. So we start off in exactly the same way. Chuck has spotted the alert raised by AppDynamics as performance deviation. But in this case, he can see that rather than just generally there's some problem in the mainframe, he can see that it's a specific database. He can see exactly what's going on there, and he knows exactly who to speak to. So he phones up Jim, who very quickly finds the problem, debugs it, gets the application back up and running properly. And so what this gives you is the ability to do much, much, much faster problem isolation and less application downtime, right? So you're going directly to the problem, you're getting it resolved, and also you're not pulling in a whole bunch of people that, frankly have probably got better things to be doing than to doing some, serious analysis of a problem that isn't even in that area. So with that, I'm going to hand over to our chief architect for this project, Aaron, who's going to show you how this works in real life.
Great, thanks Nathan. So we're going to switch over and we're going to do a bit of a live demo here to show you how this looks. So I'm going to be playing the role of Chuck first, right? So I'm the person who gets notified, right? I've set up health rules and AppDynamics about my application, and I'm going to get some sort of a notification when there's a problem. So I come into AppDynamics and I see my online banking application, has a status of red here, right? So something has gone on with my application. So I'm going to take a look at that to see if I can figure out what's going on. Before I dig into the problem here, I just want to talk a little bit about the application composition. So you can see over here on the far left-hand side there we have an HTTP server, right? So this is like an online banking you would use from your mobile phone, right? So there's an HTTP server, there's a web application server, and then that web application server makes several different calls out to different backends, right? So I've got a call here to a MySQL database, and then I've got a call here that's just to a cloud, which is labeled mainframe. As Nathan talked about, so this is kind of the as is today, right? I have application code, I'm using services back on the mainframe, but I don't have any visibility into what those are, right? All I know is the number of calls I'm making and the elapsed time. So I can get notifications on if it's slower than normal, but I really have no visibility into why. So that means if there's a problem with my application, I'm waking up the whole mainframe team figuring out what the problem is, and they've got to root through their tools to figure out what's going on. And those tools, they're very deep, they're very technical, but often they lack the business application perspective, right? So now, with our solution, you can see up on the top, we have a couple of additional nodes. So this flow going up to the top to this tier called CICS, that's our kicks tier for this application. And I've actually got two nodes in this that I can click on, and I can see the two nodes. So these are two different kicks regions. So I have two transaction servers running, and they have applications that have transactions that are flowing through these two regions. Now on the mainframe, typically we scale up vertically, right? So those two particular kicks regions, so I have kicks CB05, kicks CB06. They are likely running hundreds, or if not thousands, of different transactions. What's really nice about this solution is we discover for this particular application which of those transactions running on those two different kicks regions are pertinent to this application. So that we discover that, and that way you automatically get that filtering, right? So you're not looking at all of the transactions on these two different kicks regions. I'm just looking at the ones that are for my application. And then I can also see from that kicks tier, I have a callback to a DB2 tier. So I'm also having those kicks transactions calling DB2 on ZOS. So we have here a nice visibility into where that call is actually going. So now if I go back to problem determination mode, so I can see over here in my business transaction health, I have one critical and I have two warnings. So I can click on that, and I can see that these are the transactions that are discovered by AppD, and I can see that people are having trouble with the application, right? They're having a hard time logging in, they're having a hard time doing money transfers, and they're even having a hard time doing balance inquiry. So as they're using their mobile devices, they're just seeing that spinning wheel, right? So they're getting a bad user experience. So I can drill into these different applications, and I can see, instead of the whole application, now I'm seeing the components that are just involved for one of those business transactions. And what I can do from here is I can look at the snapshots that we've collected. And you can see we have sorted by severity. So I have some that were kind of slow, like 3.5 seconds, creeping up to 4 seconds. And then we actually had some that went up to 28 seconds, right? So something really significant happened in the system to make our transactions go from 3 seconds, which might be okay for an end user, up to 30 seconds, they're probably going to give up, right? They think something's broken. So now I can actually click on any of these individual snapshots and see this specific transaction. And it gives me that detail back into the Z side. And if I click on the waterfall view, I can see the elapsed time spent in this transaction in the different parts of the application. So I can see here, the total time was 28 seconds. And if I look down, through the layers here, the different application segments that were called, I can see, so I know DB2 was my end segment, and I can see that my application time for this transaction is being dominated by that DB2 segment, right? So I have 25 seconds out of my total transaction time is actually being spent in DB2. So at this point, I have enough information to talk to the DB2 people on Z, right? I don't have to wake up the MQ person or the Kix person. I know I'm having a problem with this transaction. It's specifically in DB2. And I can actually confirm that. I can go, AppDynamics does baselining on these metrics. It has already flagged this as anomalous, but I can go look and see, what's typical for this transaction. And so I can go see what the average response times are and what the variation has been. So I can see that, normally my calls to DB2 are like 3 to 4 milliseconds, right? So almost instantaneous. And then I see, I had this huge spike that creeps up. So this just gives me that extra confirmation, this really is the problem. The application's not behaving as it normally does. So this allows me to page out the DB2 guy who's on call from the Z team, and I can tell him what's going on. So from this perspective, I'm going to switch over. I'll show you a little bit of the Omegamon screens that Nathan showed, just to show you what the other side sees. Okay, so as Nathan said, this is what our users use who do the deep dive monitoring on the ZOS side. And this view is actually a situation status tree. So they can set thresholds on metrics from the Z side as well. And so if I'm the Z guy who just got called out and they said there was a problem with DB2, what I'm going to do is I'm going to confirm. I'm going to come here and I'm going to look to see what the issue is, and I can actually see that there's a situation that's been fired, and it has to do with DB2 locks. So this tells me that it confirms from my tooling that what they're seeing on the application side is actually something that has come up. I'm seeing a lock here. And so what I can do from there is I can actually go into the Omegamon tooling, and I can go look for any sort of lock conflicts that are occurring in that DB2. And this table shows me exactly what's happening, right? I can see that we have Kix CBO5, if you remember, that was one of our Kix regions involved in our application, and it's a waiter, right? It's waiting for a lock, and that's really what's causing impact on our business applications. I can also see from this view who the owner of that lock is. I can see this A Young person, I don't know who he is, but he's causing trouble, right? So he's running something, and he's got an exclusive lock on a table that's also being used by my online banking. So now, as a DB2 guy, I know what's going on. This is impacting my production environment, so I'm likely just going to kill off this job, right? I'll go figure out what's going on later, but I'm going to kill it off, restore service. So what's good about this from the Z side? So if I'm the Z guy, these tools, they do show me like if there's a wait on a lock, I can set a threshold for that, but what I don't see is the business impact, right? So I can see I have several different alerts going on in my tooling, but oftentimes, unless I'm very senior and I have a lot of experience about what means what, if I'm a junior guy, I don't know, which one of these things is important? I don't know. But now, as we surface this up through AppDynamics, we have that business context, and that person can tell me, you're impacting online banking. So that's really the value that we're adding here on both sides. And that's the demo, so I'm going to hand it back over to Jonah.
Thank you very much. Thanks. So I just wanted to go over some of the current technology that we support in IBM, in the new IBM APM Connect technology. So when we make this generally available, on the left-hand side here, you'll see the distributed side. So this is essentially calls coming from AppDynamics instrumented technologies. So if you have an agent on a Java app, .NET, Python, whatever it may be, or if it's coming through MQ, as it goes into the mainframe, now we're one step over, we're inside the mainframe, we'll be able to trace those transactions as they either go into MQ, JMS, or native MQ, but it does depend on how your application is constructed. We may have to do some custom correlation rules, depending on how it's set up for native MQ. And then we also support HTTP calls directly into CICS. And then from that point, we trace through the different CICS regions, as they call each other, back into the backend DB2 or IMS DB. Now, this is what we support today, but we do have an aggressive roadmap to increase support as well. Before I get into the roadmap, this is the architecture for the agent. So essentially, on the top here, you have the AppDynamics instrumented transaction flow. And then below that, you actually have instrumentation in CICS that allows us to do the correlation. And as Aaron stated, we only look at transactions that are coming from an AppDynamics instrumented agent. So the overhead is very low. So part of this is creating a lightweight way to solve the exact problem that Nathan laid out for you. And so we look at only the tagged transactions and we trace those inside the mainframe. Now what happens at the bottom here is from this container that collects the data, we bring it to a standard x86 Linux box that merges that transactional data together, sends it into your controller, shows up on your flow maps and your snapshots and everything else that's part of the platform. So that's essentially how this is set up. And because we're working with IBM on this, we have the relationship and trust, and we've made a lot of introductions between AppDynamics customers and their mainframe teams because they don't know each other. They don't even talk. But we can really bring these teams together and allow them to work together to achieve the greater goal of solving problems faster and opening up the data that is relatively unknown today. And so our goal is to regularly release. We'll be doing quarterly releases and quarterly betas as we move this product forward. We have an aggressive roadmap to increase support. And so some of the things that we're going to be focused on in the shorter term is adding support in for things like CICS Transaction Gateway. And IBM has some great new technology. I've actually spoken to several customers in the last couple weeks testing the ZOS Connect, which is a new RESTful API service to connect into mainframe. So it makes it much easier for app developers to access mainframe data using lightweight REST APIs. And then IMS Connect is also kind of part of that. And then we'll also trace back in on the mainframe side into IMS transaction management, WebSphere application server, and IIB. Similarly, you've probably heard a bit about IIB on Linux. So that is another product that's being developed at AppDynamics. And IBM has actually been helping us quite a bit with learning how that works and how to instrument it. So this is really providing extra visibility inside Z. And so that's kind of the goal here.